Welcome to the Virginia-class CGN ship brief. All right, so our story begins in the late 60s, early 70s with the formulation of the concept and a contract definition procurement strategy. This is a strategy that began under the JFK administration and is still used today, just in a different it's been modified over the years. But the idea is to have more bureaucratic control from Congress, working with the Pentagon to have clear lines of communication with the shipyards and military industrial complex. It's a very formal, bureaucratic, administrative way of defining what the Navy wants, how much it's going to cost, how long it's going to take to build. This all began in the 60s and has evolved into what it is today. The downside to this is that it was rife with corruption, basically, because we included Congress in the procurement process, not just the funding process. They began to receive money from the military-industrial complex for re-election, their campaign funds, and that spun into what we have today, where we have this triangle of the military-industrial complex, the admirals and generals in the Pentagon, and then the Congress and the Appropriations Committee. And nowhere in that triangle is the U.S. voter. But that's kind of how it works today. And this all began, like I said, in the 60s. And has evolved over time. And so this bureaucratic process is what's going to define how the Virginia class is built. In addition to this information, Admiral Rickover had done a number of studies and had reported to Congress. Keep in mind, Rickover has a very close relationship with Congress at this time. He compares multiple nuclear reactors to, say, 2 gas turbines on a cruiser of this size, and found that it's more cost-effective to go with the nuclear option. And this is not surprising, seeing how he is on the nuclear side of the house. He's working at Bureau ships at this point, and developing nuclear reactors for submarines, of course, even though he was instructed to make them for destroyers. But he's saying, if we were to go to war, we would save ourselves time and money and have more capability if we didn't have to stop to refuel at sea every couple days. You could maintain high-speed operations all the way across all the oceans around the globe without having to stop to refuel, because the nuclear reactors can operate at full steam for, long periods of time, weeks on end, months on end. Whereas a conventionally powered gas turbine, you have to stop and refuel, and you can't do that, or it's difficult to do that at very high speeds. It's also dangerous to do it at high speeds. Things could go wrong. Ships could get, damaged before they even get into combat. So there's a lot of risk factors if you're going to be at war. And remember, this is during, the height right after the Cuban Missile Crisis, right? So they're thinking war is, probably going to happen. So between the concept formulation process and Rickover's recommendation, they decided to build the next generation of ships with nuclear reactors, and the Virginia is one of those. The improved Standard missile is just coming into use right now. It's called the SM missile. So we have SM1, 2, all the way up to 6. We'll be beginning with SM1 with the Virginia today. The SM2 does come into play at the end of the Virginia's career. Speaking of career, the Virginia-class cruiser has one of the shortest lifespans of any warship in the really any Navy at any time. It only lasted about 15 to 18 years. Very short lifespan for this, especially for the cost. And part of what ruined, or what caused it to have such a short lifespan, was the cost. The operating cost of these things was incredibly high. So after they've had these out in the water for a few years, they're like, we can't maintain these. If we're going to refuel these, we might as well just build a new ship. Anyway, back to the beginning, the origins. This was originally designated a DLGN, and that stands for Guided Missile Frigate Nuclear Powered. I'm not sure how they got that letter configuration from Guided Missile Frigate, but that's what they called it, DLGN. But it was later changed to CGN, Cruiser Guided Nuclear. The follow-on class to the California class was also nuclear powered. It came first. This is a follow-on to that. The one that comes after this is the Ticonderoga. 4 are ordered for construction, so a rather limited run here. And the reason for this is a transition period for the Navy. not just in concept formulation and contract definition, not just in nuclear power, but also with sensors. The new radar sensors and beamformers and processors are coming online. We're switching from solid state and vacuum tube computers to an all digital network. Fiber optics are becoming a thing as early as the 1970s on board ships. And so they don't want to, mass produce a ship that's going to be outdated by technology by the 1980s. And they don't want to build a ship in the 1970s and say, well, it's already obsolete. So they just have a limited run of 4. All right, all 4 of these ships are going to be built in Newport News, Virginia. That's part of the Hampton Roads complex, if you will. There's a number of naval bases, and it's rather huge. Virginia has a huge naval presence, whether it's construction, ports, special forces, and this is part of that conglomerate. It's a Huntington Ingalls Industries now. It's had several owners over the years. 94% of the contracts are Department of Defense. There's a few sources that say this is 97%. The history of this facility goes all the way back to the 1800s, and they have constructed over 300 naval vessels, many of those nuclear submarines and aircraft carriers over the centuries. And it's one of only 2 companies in the United States that is capable of building nuclear submarines. They have this, and they have General Dynamics up in Connecticut. California by the numbers. She's a big beast. Her length is 586 feet. Her beam is 53 feet wide, displacing over 11,000 tons. Despite this, she can make 30 plus knots, powered by 2 D2G General Electric nuclear reactors, turning 2 shafts, producing 6,000 shaft horsepower. She does shoot the Standard Missile. She'll start with Standard Missile 1. Later in life, she'll get the SM-2. She also shoots the ASROC, which is the anti-submarine rocket that is both conventional and nuclear capable. On the second half of her life, after midlife upgrade, she'll be able to shoot Tomahawk missiles. She'll have 2 quad launchers installed. But from the beginning, she'll have 2 quad Harpoon launchers installed. So she has Harpoons from the very beginning. She also has 2 Mark 32 torpedo launchers that shoots the Mark 46 torpedo, and 2 deck guns, the Mark 45 5-inch guns. She will be installed with the 20 millimeter Phalanx close-in weapon system. In some cases, this is not available immediately. She'll get this later on after she's commissioned with the first couple hulls. The SLQ-25 Nixie is a torpedo decoy she can tow behind her. She will carry 2 of those. And the SLQ-32 electronic warfare system is used for defeating incoming missiles that are radar guided. Her air search radar is the SPS-49, the same as on the Ticonderoga, the SPS-48 3D air search radar, and SPS-67 surface search radar, so multiple radars. She has the SQQ-26 bow sonar, which is a medium frequency and high frequency, rather short range, limited in range sonar. She's not designated an ASW vessel, although she does have ASW capability, especially with the helipad she has on the back, which we'll get to in a second. The Mark 74 missile fire control system is used for guiding the SM rockets. The Mark 86 gun fire control system is for the 5-inch guns. And she has the Mark 114 ASW fire control system for communicating with helicopters. She has 4 SPG-51 radars. Those are used for directing missile fire, so that will be associated later on in her life. And the helipad is a failed design that was installed on the first couple hulls. It's not clear if it was installed on all hulls. The information is rather ambiguous about this, but the helipad had an elevator on at least hull 1 and hull 2. And the idea was they would land the helicopter on the helipad. The helipad was itself an elevator, hydraulically operated, and it would lower down into a hangar. And then they could close the top of it after it was lowered, and the helicopter would be, underneath this cover. Well, the cover apparently was never watertight, so salt water was always raining down on top of anything in the hangar, like the helicopter, and all of the elevator machinery. And it was a real mess. They had to do freshwater washdowns daily, sometimes multiple times a day, just to keep the equipment from, collecting salt from the salt water coming down on it all the time. And eventually this helipad was just removed. But know that she does have SH-2 helicopter lamps capability. The first couple hulls definitely do have the helipad with the elevator. It's not clear if Hull 4 had it. It appears that it did not, but I could not confirm that. All right, let's move on to the missiles. SM-1 standard missile. This is the RIM 66, RIM 67, and they have different variants of these particular RIMs. This is operational 1967. It's a medium-range surface-launched missile with both passive and semi-active homing. Has a dual thrust rocket motor. That's for the RIM 66. There at the bottom, you can see the RIM 67 has the extended range mid-course booster rocket with mid-course correction right there. And the SM-1 was phased out in 2003. The SM-1 would outlive the Virginia. Here's the Mark 26 guided missile launching system. These are the dual rail arm launchers that hold the missile before launch. Also has the magazine below. The Virginia never got the modified 1 and 2 magazine, so it only ever held 24 missiles per launcher. You can also shoot the ASROC from this launcher too. So it wasn't always the SM missiles. Here's a picture of the mounted torpedo tubes. There you can see the Mark 32 is there. It shoots the Mark 46 torpedo. It's a pneumatic launching system, which means it just blows compressed air into the rear, pushing whatever's in the tube out the front. And it's about a 1,500 PSI air flask for that. Here's the Mark 45 5-inch 54 caliber lightweight gun being fired from the forward position of one of the Virginias. This is operational 1971. It's a fully automatic gun. It loads itself. It's directed by radar. It can be manually controlled, but normally it's just directed by radar. Has a range of 13 nautical miles, can shoot 20 rounds per minute, has a magazine of 500 shells. It's used for anti-ship, but does have anti-air capability. It can detect, track, and rain fire down on airborne contacts. Here's the Mark or AGM-84 Harpoon. Its 2 quad launchers are mounted on the bow, just forward of the bridge, but behind the forward deck gun. This variant of the Harpoon came into service in 1977. The air variant came in a couple years later. The Harpoon is 15 feet long, 13.5 inches in diameter, carries is about 1,470 pounds, and has a speed of 855 kilometers. Pushes 660 pounds of thrust for over 60 miles of range. There are multiple variants of this weapon now, but back then it was only about 60 miles range. 660-pound Des-Tex explosive makes up almost half the weight of the entire weapon. It's an anti-ship missile designed to shred aluminum and pretty much anything it hits and then set it on fire. That's the idea of this weapon, is to set ships on fire and let the fire do the majority of the damage. It is a low-level sea-skimming weapon with a mid-course correction. You can give it a waypoint. So it flies to one waypoint, will make a turn, and then go from there. Here's the Tomahawk upgrades. Again, they did not have these Tomahawks at time of commissioning, but after their midlife upgrade, they get 2 of these quad box launchers, armored box launchers, or what they call them. These enter service in 1983. They are nuclear capable. They can carry the W-80 warhead, but they almost always just carried the 1,000-pound conventional warhead. 550 knots is total speed, has a range in excess of 800 miles. And the cool thing about the Tomahawk is that it has terrain following. So not only did it use the military version of GPS as early as the 1980s, long before civilians ever had GPS in their cars and on their phones, it could also take a look at the terrain that it was under or flying over, looking down on it, and it could reference a map in its memory, and it would know where it is. So because it knew where it was in the map, it would know what's in front of it without having to look forward. And it was able to go around obstacles, whether it was cities, mountain ranges. It could maintain a low-level flight over uneven terrain through terrain mapping and terrain following. Very high-tech for the 1980s. The Mark 15 Phalanx close-in weapon system. They had 2 of these. Again, these weren't always installed right away. There's a case coming up where it gets these after commissioning, but eventually they do get these. This was tested in 1977 on board USS Bigelow. That's a different class of ship entirely, but became operational in 1978. Total weapons system consists of two 20-millimeter gun mounts. Each mount has its own search track radar. It's completely independent of all the ship's sensors. Automatic engagement of anti-ship missiles and aircraft. Also has a manual mode. So if you need to target something manually that the 5-inch gun can't hit, or the 5-inch gun would be overkill for, you could manually traverse these onto a target. It has a 980 round magazine, shoots about 3,000 rounds per minute. Armor piercing discarding sabot was replaced by tungsten rounds in 1988. The SLQ-25 Nixie towed decoy. Here's a very rare picture of the torpedo decoys. This has been very sensitive information until recently, but now this is out on the public domain, so we put it in the lecture here for you. This is a towed underwater acoustic projector, which is a fancy way of saying, speaker. It makes noise. And the idea is to just be very loud and attract acoustic homing torpedoes. And, just by being louder than the ship, the idea is that it'll present itself as either a larger target, or it would just distract the torpedo long enough for the ship to get away. And they can tow these things, thousands of yards behind the ship, keeping it outside of, the idea is to be outside detection range. And she does have two. I saw a question on the Discord that do they tow both at the same time? They certainly can. There's nothing stopping them from doing that, but normally it's one at a time. If they do tow both at the same time, they run a risk of getting them tangled together, and that's a nightmare to untangle. But if they do that, they tow one long, almost at maximum distance, and then one at a more of a short range, mid-range distance. But that limits their operational capability in terms of rudder turning. They can't do sharp turns, because then the lines would cross each other and you would have a tangled mess of torpedo decoys. Here's the SPS-49 air search radar, same radar that was on the Ticonderoga. It's very long range, 2D radar, just gives you range and bearing. But you can see for 200 plus miles with this thing. It's very, very long range. It operates in the 850 to 942 megahertz, has auto detection, estimates contact solution for the operator. In other words, gives them the contact's course and speed. It's medium pulse repetition frequency. Upgrade increases detection of the stealth. The Virginia class probably didn't get that upgrade, but just know that this SPS-49 is still in use today. Like, this is one of the primary air search radars that the Navy uses, so it's gone through multiple upgrades over the years. It has built-in automatic fault detection, which is a big thing. During World War II and the Korean War, and 50s and 60s, a lot of the troubleshooting the crew had to do on these systems was down at the component level. They were going down and looking at resistors and capacitors and seeing where the problem was. So having these systems come in that are very complex, having their own detection or fault detectors, and tell the operators, hey, the beamformer has a problem, you at least give the operators somewhere to go and look, and then they can just replace that entire module instead of troubleshooting at the component level. And this has that. All right, here's the Mark 74 Tartar guided missile fire control system. This uses the SPG-51 radars that we talked about. These are the radars that will illuminate the targets for the standard missiles, so the missiles can go in and home in on them. You can see that degrees of elevation are -30 to +83, so all the way down to the waterline, basically, and then almost straight up again. Can target just about anything that's in that range, in that arc. The Mod 15 adds X-band continuous transmission that is installed for the Virginia, and part of the NTU, the new target upgrade program. The target can target multiple aircraft at once, which is an improved capability over previous generations of ships. This is very similar to Ticonderoga Spy 1 radar capability, but not quite. This is the stepping stone before the Ticonderoga. This is what led to the generational step that is the Ticonderoga and later on the Arleigh Burke. This was what led to that. Here's the Mark 86 rather, fire control system. This is for the guns. Know that this is a system of other radars, like the SPG-9 radar is the ball right there. So whenever we say Mark 86, we're talking about a cluster of other sensors. Okay, and here's a picture of those sensors. This can direct fire onto targets. Again, it's for the 5-inch guns and has surface and air targeting capability. All right, let's talk again about the failed helicopter deck. I scoured the internet to try and find as much information about this as possible. It's almost as if the Navy wants everyone to not know this thing even existed, because it was a failed design. It was the Achilles heel, if you will, of this ship. Well, the ship was great at demonstrating the technology of the Standard Missile, over-the-horizon targeting, and it was a great cruiser. On the rear end, the aft end of the ship, they had this helicopter deck that was an electrical mechanical elevator that was lowered into the stern of the ship. But whenever they tried to close the roof over the top of it to protect the helicopter after it was lowered, that roof was never watertight, like I said. Always leaked salt water down onto the helicopter. It leaked it down onto the elevator mechanism itself, and they were always out there with fire hoses just washing the salt water off everything. And it was just a maintenance nightmare, constant attention to keep this thing clean. And it was finally removed during their first dry dock availability. So the picture that you see now is really what it was after that. They also, whenever they removed the helicopter deck, they added some Tomahawk launchers as well. So anytime you see the picture of this ship with the Tomahawks on the rear, know that the elevator has been taken off. So that's the story of the failed helicopter deck. And this will be the last time that we see a helicopter elevator on a cruiser. From this point forward, the Ticonderoga, the Arleigh Burke, they're all going to have, the ones that do have helicopter capability will have the hangar right there on the stern with the deck already lined up, ready to park the helicopter. And then they'll move on to invent the rapid lowering system where they can hook a cable to the bottom of the helicopter and just wrench it down in high sea state at a very high speed and safely get the crew back on board. All right, let's talk about these hulls. USS Virginia CGN 38. Her keel was laid in 72, launched in 74, and commissioned in 76. She spends 1977 finishing her sea trials. A lot of these sea trials are done down in the Caribbean. Remember, all these ships are being built on the East Coast in Virginia. And so whenever they do their sea trials, they go to the VACAPES, which is the Virginia operating areas. And from there, they go down to the Caribbean and do a lot of work down there. Well, in 1978, she operated along the East Coast, went down to the Caribbean, and then went over to Europe and did a few port visits up in the Denmark and Norway area. In 1979, she returns to Europe for a med cruise, this time going through the Straits of Gibraltar and operating in the Mediterranean. In 1980, she goes even farther. She goes over to the Indian Ocean and does a Westpac. Now, it's not clear what happens during this Westpac, but she has to pull in to get repairs done to her sonar dome. It doesn't say what she ran into or if she ran into anything, but she certainly didn't run aground. But something happened to the sonar dome where she had to have repairs. It's possible that the sonar dome just failed. Remember, they're pushing these ships around for long periods of time, 30 knots plus, and this is one of the first ships that can sustain these speeds for literally weeks, like I said. So it's possible that the sonar dome just wasn't prepared for that construction-wise and just failed on its own. 1983, she does another med cruise, but this time there's a lot of drama going on with Lebanon. There's a civil war in Lebanon. They end up killing a bunch of Marines with a vehicle bomb, and they capture a Marine, I want to say colonel, and they torture and hang him. It's terrible. So during the Civil War, we're trying to defend the leadership or the of Lebanon on this hill. This hill has a university that students are at. It's also got the presidential palace, and they fire 300 rounds, 305-inch rounds in defense of this hill, this Souk El Garab. It's also like a very fancy, destination. Back before the Civil War ruined everything, this was where all the rich people would go to spend their time. And if they went to visit Lebanon, this is where that they would go. All right, so the other upgrades. All right, there you can see a great picture of the Tomahawk armored box launchers on the aft end of the ship, and clearly the helicopter pad is completely gone. They just completely get rid of it. In 1984, she enters dry dock for a significant strike cruiser upgrade. So she's going to be a strike cruiser by designation from 1984 forward. This is where she gets the phalanx installed, the Tomahawk missiles installed. She's able to shoot the SM-2 missile after this upgrade. Helicopter hangar and elevator are completely removed. And from here, her next deployment is in 1990 to Desert Shield from the Med. So she's going to be in the eastern part of the Med, very close to Israel and Syria, in that region, and supporting Desert Shield from there. In 1991, she launches the longest range Tomahawk strike in history up to that point. So she's shooting it over, those territories and into Iraq. And in 1994, she's finally decommissioned. And recycled. These ships are no longer around. They're torn apart. So here's a great infographic of the Virginia-class nuclear-powered cruiser after its refit. So this is all the upgraded systems. And I want to point out in the back, you can see the Mark 143 armored box launchers. They have the TASM or TLAMs. TASM is the Tomahawk anti-ship missile. The TLAM is the Tomahawk land attack missile. They have a number of new sensors like the QE82, ultra-high frequency satellite communication. They have the SPS-40 2D long-range search radar, Navcom EARN 25 tactical navigation system, and SPS-55 surface search radar. Lockheed Electronic SPQ-9A multi-purpose surface search radar that directs the guns, the 5-inch guns, onto target. She has 2 of the Mark 141 quadruple Harpoon launchers that's kept over from her original design. Of course, the 5-inch guns on the bow and on the stern, with 2 twin rail launchers, again, forward and aft, firing those SM-1 and SM-2 missiles. Very good infographic. All right, let's go to Hull 2. Hull 2 is USS Texas, CGN 39. Keels laid in 1973, launched in 75, commissioned in 1977. She goes down to the Caribbean for her sea trials in 1978, just like the Virginia did. In 1980, she's deployed with USS Enterprise to support the failed Operation Eagle Claw, an attempt to rescue American hostages from Iran. If you guys remember, that was a botched mission where we sent in, Rangers, Army Rangers, and I believe some Marines into the deserts of Iran with helicopters to go in and try to extract these hostages. And they ran into some mechanical failures, compounded by a sandstorm came in, and it was just a disaster. We ended up losing a plane, a couple helicopters, and some people were killed, and it was just a mess. But she was part of the fleet that was supporting that. In 1981, she goes into maintenance period where she gets the Harpoon launchers installed in the Sea-Whiz close-in weapon system. In 1983, the Transglobal Cruise and Home, she moves her home port to San Diego after going around the world. In 1984 to 87, she does another dry dock upgrade period. This is where she gets her Tomahawks. They remove that helicopter deck, and they get the SM-2 missile. They're SM-2 capable. They can still shoot the SM-1, so don't think that they just shoot SM-2 only at this point. They certainly could, but they can do both. In 1989, she does drug ops near South America, but on the Pacific side. And in 1991, she does her final deployment. This is in support of Desert Storm in the Persian Gulf. She is coordinating and supporting minesweeping operations. Now, she's not a minesweeper. Other ships are doing the minesweeping. She's simply coordinating that effort. USS Mississippi, CGN 40. This is Hull 3. Her keel's laid in 75, launched in 76, and commissioned in 1978. Where does she do her sea trials? That's right, the Caribbean. She goes down to the Caribbean in 1979. In 1981, she does a med cruise. She's present at the Gulf of Sidra incident involving the American F-14s shooting down 2 Libyan Su-22s. If you're not familiar with that, definitely Google the Gulf of Sidra incident. It's a very interesting study on actual combat between F-14s and Soviet-built, but flown by Libyans, Su-22s. And it's a very one-sided victory for the Americans. 1981, rescued 19 crew members of a Greek cargo vessel before it sank in the Med. Not a lot of details about that, just know they were involved in getting a helicopter over there and helicoptering off 19 crew members. In 1989, she does a Westpac with USS America. In 1990, Desert Shield and Desert Storm support with JFK Battle Group. So all 3 so far have been involved in Desert Shield and Desert Storm. In 1991, she supports amphibious UN peacekeeping invasion of Haiti. So Haiti has had a number of civil wars over the years, and the UN finally stepped in 1991 and said, all right, enough of the violence. Civilians are getting killed in the streets. And so they occupy Haiti with UN peacekeeping troops, and she's off the coast supporting that. In 1995, 1996, she supports operations in the Adriatic Sea, enforcing the arms embargo on Bosnia. That's part of the Bosnia conflict over there. It's a real mess. It's very complicated. Just know that she was supporting those UN operations from the Adriatic Sea. In 1996, patrolled the Florida Straits after a Cuban MiG-29 shot down 2 Cessnas fleeing Florida. I was underway when this happened, so I don't know a lot about this. But apparently there was a non-profit group or a non-government organization, an NGO, which is code for CIA in some cases, and I'm not sure if that's the case here, but they were basically taking Cessnas from the Bahamas and Miami as well, but especially the Bahamas, flying them at low level into Cuba, into these, just man-made runways, like not official runways, just like grass strips, anywhere they could land a Cessna. And they would pile in some people, refugees, if you will, and fly them back to Miami. Well, the Cuba got tired of that happening, and they sent out some MiGs and strafed these Cessnas and killed everyone on the planes in 1996. So after that happened, they sent USS Mississippi down there to keep an eye on things, keep that from happening again, which worked. That was not repeated. They did not shoot down Cessnas after that. And in 1997, USS Mississippi is decommissioned. USS Arkansas. All right, USS Arkansas is the last of the Virginia class. Her keel's laid in 77, launched in 78, commissioned in 1980, and does her sea trials in 1981 off the coast of Puerto Rico. In 1982, she does a shock test in the Caribbean deployment. This is normally done on the lead ship. I believe it was done on the Virginia, but they certainly did it again here with USS Arkansas in 1982. In 1983, she's deployed off the coast of Beirut. Remember that's part of Lebanon. There's a civil war going on over there. A bunch of Marines were killed, and so she is supporting that. Her new home port is moved to Alameda, California. So she essentially does a trans-global deployment after leaving Beirut and heads over to California, where she goes into dry dock for maintenance. In 1984, after her dry dock maintenance is done, she participates in RIMPAC 84. And that's basically a huge war game that involves a lot of nations along the Pacific Rim. In 1985, she gets her Tomahawk and Sea Whiz upgrades. There you can see on the back, she has the Tomahawk launchers there now on the right-hand side of the lower picture. In 1986, Westpac and Med cruise to the Med. In 1990, she does an extended drug deployment in the Caribbean, operating down there. In 1991, she participates, she is in the Persian Gulf after Desert Storm, but she participates in the operations that are after that. I believe Enduring Freedom was the name of the operation after Desert Storm. Anyway, in Persian Gulf, she in 1996, she returns to the Persian Gulf and is part of Operation Desert Strike into Iraq. And that's part of the enforcement of the no-fly zone and things like that in Iraq after the first Gulf War. In 1998, she is finally decommissioned and recycled. She is the last of a line. So the first one being constructed in 1977, at least that's when the keel was laid, to 1998 is the lifespan, if you include the construction time from hull 1 to hull 4, almost 20 years across 4 ships. But again, like I said, this is a transition period for the Navy. They have all this new technology coming at them at the same time, from shipbuilding administrative bureaucratic processes being changed, new technologies in ship propulsion with nuclear power, new technologies with radars and missiles, with what will become the Spy-1 radar system. Not installed on this one, but this is the predecessor towards it. That's what they're moving towards. The standard missiles, SM-1, SM-2. Tomahawk has a great new capability, and there's a flaw in the design, going back to the helicopter pad. The helicopter elevator was a disaster, and they got rid of it as soon as they could. It's not even clear, like I said, if the Arkansas even ever had the helicopter pad. According to photos that I've seen, I've never seen Hull 4 with the helicopter pad. So it appears as if they didn't even install it on that one. That's how bad it was. This is basically an upgraded California class. So California class came before the Virginia class and had similar capabilities. California was nuclear powered. A lot of lessons learned in this build were used in designing and building the Ticonderoga class. The Achilles heel of this really was the operational cost. She had to be refueled in the 1990s if they were going to continue operating her. And the operation, or the cost of refueling these reactors, because of the way the ship was built, how deep in the ship the reactors were, and all the systems connected to the reactors, it was just abhorrently expensive. I mean, they could build a new, smaller ship like a frigate for the same cost as just refueling this one. And the Ticonderoga was already on the drawing board. This great ship with enormous capability that was going to outclass the Virginia class here as soon as it was built. So they said, hey, we're not going to spend the money on the refuel like they had planned. They had planned on refueling these whenever they built them. It was going to have like a 38-year lifespan, and it ended up being, a little less than 20 for operational lifespan. Mostly because the cost of the refuel was just too much. And the capabilities were going to be superseded by the Ticonderoga significantly. Like I said, this is the last time we see a helicopter elevator on a large surface combatant. You'll see aircraft elevators, of course, on the LHAs, on the aircraft carriers, of course, that continues. But as far as elevators, aircraft elevators on cruisers, this is the last time we see it, because it just doesn't work very well for this type of ship. She is a strong ship for her time, but her time was short. It was only 20 some years, maybe less than 20 years operational time. But whenever she prowled the seas, she was very capable. She was very fast. She had the most modern surface-to-air missile available. She had very long air detection and a lot of guns. She had 2 5-inch guns. She could lay down some fire if she needed to, including shore bombardment. So very impressed with the Virginia class. She was a ship to be respected during the 1980s. All right, well, that's that for the Virginia class. Really good, subject. I want to thank everybody on the Patreon side of things. You guys make this possible. Big tip of the hat to Scott Borg, who is just donating an immense amount of money right now. Thank you very much, Scott. You are the man. Department heads too, Adam Morgan, Harpoon Henry, Kelly Martin, and William R. Collier Jr. And of course, our division officers filling out the boardroom here, Alexander Huff, Brendan Ferry, Chappie James, Jason Wang, Jeremy Edwards, Joel Corrent, DJS 4000, Jordan Vazraka, Josh Warnick, Robbie Stahl, Sean O'Neill, one of our very first, by the way, Sean O'Neill, one of our very first Patreons, and Fraser Disney. Thank you guys. And be sure and check out our Discord channel. We have a Discord channel now for the Patreons, and appreciate you guys' attention. Next month, we've already got it picked out. We're going to do another surface ship, but we're going to move to Russia. Russia's coming up next. I'll see you guys then.